do a little problem solving. Kimberly is driving a go-kart on a huge circular track. She is 2 miles from the DJ at the center of the track. So let's put that information in first. 2 miles from the DJ. So the DJ is here at the center of the track. She's 2 miles away from him when she's on this large circular track, which means that our radius is 2. We're 2 miles, but we'll just write 2 for now. And she is 30 degrees away from reaching the northernmost point. Well, here's the northernmost point, and if she is 30 degrees away, that means she's about here, right? That's my angle theta, and this is 30 degrees away. If she started at the east, actually let me write that in, that this from here to here is 30 degrees. If she started at the most eastern point of the circle, so she started here, how far is she from where she started to the nearest tenth? And what it should say is along the circular path, right? Because she drove on this circular path. So she started here, she drove along the circular path, all of this, and now she's right here, and this is the length that we're looking for. So what we're looking for is a path around the circle. Anytime we are traveling on a circular path and we go all the way around the circle, that's called circumference. Right? It's sort of like finding the perimeter, but when it's a circle, we use the word circumference. So what we're looking for is not the entire circumference, but we want just a fraction of it. So let's figure out what fraction we want. Well, if she was going all the way to here, that would be easy to see, right? That's a quarter of the circle. But she's only gone this much. So what is this angle? Well, if she's 30 degrees away from this 90-degree point right here, then this angle that we're looking for, this angle here, must be 60 degrees. Right, so what we're looking for is 60 out of 360, because we know that the total number of degrees is 360. We're looking for just a fraction of that. We want to know just 60 out of the 360. And that simplifies to 1/6. So we're looking for 1/6 of the circumference. The formula for circumference is 2 pi r. So 2, and we're going to approximate with, because it says nearest tenth, we're going to approximate with 3.14 for pi, and our radius is also 2. That was given in the problem. So our circumference, or an approximation for our circumference, I'm going to do 2 times 3.14 times 2, and I get 12.56. But remember, that number tells me how far it is all the way around the track. I only want to know 1/6 of that number. So there's one final step, and that's to multiply 1/6 times my circumference. Now, when you're doing that on the calculator, that's the same thing as doing this number times the top and divided by the bottom. So 12.56 times 1, and then divided by 6 gives me approximately, let me change that to approximately, 2.0933, and it repeats. And so if I'm rounding to the nearest tenth, that would be 2.1 miles. All right. This is called, by the way, what we just found, where we find a fraction of the circumference, it's called arc length. The arc measure is the degrees, which would be 60 degrees. The arc length is the length along the path, which is 2.1 miles in this case. Okay, you're riding dirt bikes with your friends and you spot two other friends about 135 degrees apart and about a half mile away. Okay, so let's say you're here in the center and you spot two friends that are about 135 degrees apart. So if we start here, here's friend number 1, or let's call him friend A or her. And then 135 degrees is, remember this is 90, so 90 plus 45 would put us right here, and that would be 135 degrees. So there's your friend, and let's call her B. So there are your two friends. They're 135 degrees apart. And about a half mile away from you. It should say from you. So we know that the radius is 1/2, right? Because each friend is about a half a mile from you. How far apart are those two other friends from each other on the circular dirt bike track to the nearest 1/10 of a mile? So again, we want to find the distance along the path to get from one friend to the other. And again, we're looking for a fraction of the circumference. And the fraction of the circumference, remember this, another name for that is arc length. So let's find that fraction first. It's 135 degrees out of 360. So when we simplify that, you can divide the top and bottom by 45. You get 3/8. So we're looking for 3/8 of the circumference. All right, it's time to find the circumference. The circumference is 2 times pi times r. So 2 times 3.14, we'll use that as an approximation because it says to the nearest 1/10. So that means we have to use a decimal approximation, times r, which is 1/2. Well, 2 times 1/2 is just 1, so we get 3.14 for our circumference. Now, keep in mind that that 3.14 for the circumference is all the way around, and we only want 3/8 of it. So our last step is to multiply our circumference by 3/8. We can write it with parentheses. So to multiply this decimal by this fraction, you would take the decimal, enter it in your calculator, multiply it by 3, and then divide it by 8. So that's exactly what I'm going to do. 3.14 times 3 equals, divided by 8 equals, and I got 1.1775. So rounded to the nearest 1/10, that would be 1.2 miles. They're 1.2 miles apart. So another arc length problem. Okay, what are the sine, cosine, and tangent of theta equals 5 pi over 4 radians? Okay, so let's do a little brief review of sine, cosine, and tangent. You may have learned this in geometry. You may not have. Hopefully you did. But there's a mnemonic device that you can use to remember sine, cosine, and tangent. And it is, let me move that up a little bit. Actually, I'll write it over here. It's so, ka, toa. And so, ka, toa means that the sine is equal to the opposite side over the hypotenuse. The cosine is equal to the adjacent side over the hypotenuse. And the tangent is equal to the opposite side over the adjacent. So let's find 5 pi over 4 first. And then we'll determine what the sine, cosine, and tangent of that angle are. So 5 pi over 4. Well, I know that this is 0. I know that right here is pi over 4. And then actually, let's just mark it out. So this angle here is pi over 4. Then this angle here is 2 pi over 4, which we just write as pi over 2. Then this angle here is 3 pi over 4. This one is 4 pi over 4, which we just write as pi. So then this one is 5 pi over 4. So this is the angle that we're looking for. Whoa. Make it a little thicker. All right. So this is our angle. So the triangle that we're going to use when we're talking about adjacent, hypotenuse, all of that, is going to come from the origin. It's going to be this triangle right here. This is going to be our angle. And so in relation to this angle, this side over here is the opposite. This side here is the adjacent. And this side is our hypotenuse. So let's fill the sides in, because that's going to make it easier to find sine, cosine, and tangent. Remember when we did these in the last recording, we determined that in a right isosceles triangle, when the hypotenuse is 1, then each of the legs are root 2 over 2. If you're not sure where that came from, then you should watch the recording that came right before this one, the previous recording. So let's find sine, cosine, and tangent. Now, this is negative in the quadrant that we're in because we had to go down, and this is also negative, right? So let's do sine first. Sine is opposite over hypotenuse. So from this angle, this would be my opposite, and this would be my hypotenuse. So I would do this over this, and putting anything over 1 just means that it would be that number, right? So my sine is sine of theta. And actually, if we're going to write it with symbols, we'll just write the abbreviation for sine. So sine theta is negative root 2 over 2 over 1, so we don't have to write the over 1 part, right? Because sine is opposite over hypotenuse. All right, cosine is adjacent over hypotenuse. So the cosine of this angle is going to be the adjacent side, which is right here, over the hypotenuse. So my cosine is also going to be negative root 2 over 2. And then tangent theta, tangent is opposite over adjacent. So tangent is going to be this one over this one. So basically, it's my sine over my cosine, right? This one number was my sine, and this one was my cosine. So tangent is sine over cosine. I'm going to write it like that. Sine theta over cosine theta. And that means I'm putting this number over itself. Any number over itself is 1. So here is the sine of 5 pi over 4. Here's the cosine of 5 pi over 4. Here's the tangent of 5 pi over 4.